I'm Gaurav. At LinkedIn, I'm a part of the trust engineering team that works on exciting challenges to ensure the platform stays trustworthy for millions of our members. During the session, we'll give you an overview of the problems that trust engineering is trying to solve, and then deep dive into one of the pillars of trust engineering. So yeah, let me take you through the agenda for the day. So yeah, we'll start with the trust overview. Uh, then we'll go into like deep dive into malicious URLs, how we deal with them. Then we'll take you then we'll do another deep dive into content moderation. How do we do that at LinkedIn scale? And then we'll take all the questions and answer questions at the end of the presentation. So last 15 minutes will be reserved for that. While you are enjoying the talks, feel free to add your questions by clicking on that blue thing you see on the right side of your screen. Click that, add your questions into the tab, and we'll take them towards the end of the deep dives. All right. So I'll just introduce the speakers. So I'm Gaurav. I'm a senior engineering manager with the trust engineering in Bangalore. We have Arun with us and we have Neha with us. So let me just give a brief introduction for Neha and Arun. I'll start with Neha. So all of us have heard of women in tech, but if there was a subcategory called superwoman in tech, Neha would easily qualify for that as well. It is amazing to see like how she's able to scale on both breadth and depth of the tech problems we keep throwing at her. She has recently become a mom to a beautiful daughter and is juggling the techie mom responsibilities with incredible poise. So yeah, she'll be taking you through how do we do content moderation on LinkedIn scale. Arun is a staff engineer on our team. Like he's one of the most curious engineers we have. He was one of the founding members of our initial trust team. Arun has solved some incredibly hard problems in the trust space. He would be talking about one of those problems later in his tech dive. So yeah, that's about the speakers that we have today. So I'll start with giving you an overview, a quick overview of what trust does. So we'll start with trust mission. So our mission is to keep our platform safe, authentic, and transparent for our users. Like we have millions of users on the platform. They should have a safe, authentic, and a transparent experience. This is what we do. Like I have just broken it down a little bit. I'll zoom in into each one of the pillars. So when I say safe, like what does that mean? So basically it boils down to one question, like do our members feel safe on the platform? How do we do that? Right? So it's I'll take you through 3 steps by which we try to keep our platform safe. So first step is discover, where there are like multiple AI models running on every single post that is being posted on LinkedIn. And the job of these classifiers is to let us know whether the thing should go live or shouldn't go live, right? So if the classifiers can take a call, they take a call. Whenever they can't, they delegate it to a human moderator. Then that's when the step 2 comes in, which is called the review. So this is the step where the classifier couldn't take a call because the classifier was not very confident of the decision. So now a human moderator is there who will use the human intuition, and these human moderators are like trained on LinkedIn policies, and they know how to deal with content of varying severity on the platform. So once the human moderator has taken the decision, we learn. Because the classifier was like low on confidence, it will learn from the human decision that was taken. So this might look like a normal ML model for you, right? Like you make a model, then you add human intuition to it, you like create more training data, and that's how you do it. What makes it challenging for us is like, I'll just give you an example. Like you would have seen those posts on LinkedIn which say double click some post and you'll see some magic, right? Like double tap on the post and you'll see some magic. So they're nothing but clickbaits. People are trying to just make their posts viral. Like double clicking does nothing but it likes your post. So we saw that this is happening on the platform. So that was the discovery phase. Like the user flags told us that, oh, there is a post that's going viral because of no reason. It's not professional, but still it's going viral. So we said, oh, like, let's do one thing. Let's put a regex in place. If there is a double tap there, we'll not show that post. So we did that. Now the adversaries evolved. They said, okay, they have put a regex and it's not going through. Let's make it a picture. Let's make it an image. and write the same thing on the image. So now it's double tap and see magic on an image. So the regex are not catching it because it's no more a text and it's a like a image now. So then we said, oh man, like this has changed. Now let's do some OCR, like optical character recognition. So we did OCR and then again a regex on that. So when we did that, like adversary still evolved. Now they changed the image to double was there, but now they put literally 2 images of taps. So it's like double tap, right? So how do you even catch that? So that's what makes this pillar very hard, because this is like a constant cat and mouse game going on between us and the adversaries. And there is AI on both sides. Like they are also learning, we are also learning. So that makes it hard. This is the safe pillar that we have. Let's move to the authentic pillar. So as you can see on the, stay on the slide itself, previous one. So as you can see on the authentic pillar, it's all about who's who. Like when you are having discussions on the platform, are they authentic? Like if you're talking to Gaurav in a one-on-one messaging on the LinkedIn messaging, are you sure it's Gaurav on the other side? Or is it like a person who has taken over my account and is talking to you, claiming to be Gaurav? Like, so that's authenticity for us, like who's who. Next slide. Again, AI ML plays a big role over here in both authentication and authorization. So like, as it will be obvious to you, like first we try to protect that, we'll try to protect your identity. People shouldn't be able to like get into your account. Like that's what we want to do. And you have to do it in such a way that the login flow is seamless for a good user and it's as full of frictions for a bad user. So the system has to detect that automatically, that when it is a good user and when it is a bad user. So system has to like act accordingly, right? So we try to do that. We'll try to protect your account as much as we can, but still with all the best in class defenses that we have, still there are times people will take over your account and now they have gone into it. So that's where the step 2 detection comes into place. This is where our AI models try to detect like activity, like is it Gaurav? Like when Gaurav used to log in, he never used to behave like this. Like why is he suddenly sending so many messages, or why is he suddenly changing the profile picture? Why is he suddenly put Sachin Tendulkar's image as his image? Like these are not the changes Gaurav would do when he logs in. So when we see anomalies in such type of activity, we know like something is off and the account taker might have happened. When we know this, when our signals tell us this, we try to restrict the damage the rogue person can do from the account. So all the activity, we'll put a restriction on that. Now the reach of whatever you are doing might not be that much as it would have been for me, like if I was a good user, right? So that's the detection phase. Third one is recover. So now me and the other person who has taken over my account, both are claiming access to the same account, right? So there are 2 people claiming access to the same account. How does LinkedIn decide who's the rightful owner for that account? So we do that via, like, we'll ask you for an ID. Okay, if you have an Aadhaar card, give us that, and we'll, like, the other person shouldn't have an Aadhaar card. So I give my Aadhaar card, and now the person or the system that is back there will look at the card and say, okay, this belongs to Gaurav, and give it back to the person, the rightful owner. So like, what's so hard about it? Like that's how you would recover, or that's how you would validate somebody's identity, right? The hard part over here is that we have to do it for every single ID card in the world at scale. So it is a machine that has to understand that, okay, if it is Aadhaar, this is how it works, this is where the number is, this is where the name is. And if it's like some, I don't know, Brazilian ID card, this is how that's how the layout looks like. And if there is a punch on the Brazilian ID card, that means it's a invalid one. So all those nuances from across the world, from across all the IDs, have to be understood by the machine learning piece that is back there. Otherwise it won't scale. If you can't have humans looking at each and every ID being uploaded at LinkedIn scale, you can't do that. So that's the authentic pillar. What do we do on all the 3 steps? Let's move to the third pillar. So we talked about safe, we've talked about authentic. We want to keep it transparent as well, right? So what does transparency mean in terms of LinkedIn's platform? What happened to my post, right? Like we are talking about three personas over here: a creator, a reporter, and a consumer. A creator is a person who's creating a post on LinkedIn, right? And now for some reason it didn't hit live. Maybe the safe pillar did something, or maybe somebody reported it didn't hit live. So as a creator, you should know what happened to your post. We will promise you that transparency, and we'll send you a mail: oh, this didn't go live because of some professional policy violation. One thing to note here is, like, we can't give away too much, because it might be a wrong person and we might be just helping them to create the right post which can go live, and but still enough information for a good person that they are able to fix it and go ahead. So it's a very sweet spot that we have to find, like, how do we communicate, right? So that's for the creator. That's what transparency means there. What does it mean for the reporter? So you saw a post on LinkedIn which you felt was not LinkedIn worthy, it's not professional enough, and you reported it, right? So when you reported it, it will go to one of our human moderators and they'll take a call. So as a reporter, we have to tell you, did we agree with your report or did we not agree with your report, right? So if we agree with your report, like, it will be taken down, or if we didn't, like, yeah, then you have still one more step left with you. Yeah, you reported, you felt this is really not LinkedIn worthy, but we didn't agree with you, we didn't take it down. You can still appeal. You can appeal that I feel this is wrong, this is like grossly wrong for your platform, please have a relook, and we'll have a relook. So you can appeal what you have reported as well. So that's what transparency means for a reporter. What does it mean for a consumer? Like, you are not creating something, you're not reporting something, you're just reading. So this is a work in progress. Like, we also want to tell you, why do you see what you see on the feed, right? So this is a post, you are seeing it because somebody, like, you liked some topic related to this post, or your friend posted it, who's your first degree connection. So the reason why are you seeing something on your feed is what transparency will cater to for the consumer. So yeah, I've given you an overview of safe, authentic, and transparent. What does it mean in the trust world for us? However, in the next two deep dives, we'll zoom in into the safe pillar only. We'll not talk about authentic and transparent. So in the safe pillar, Arun will start and then Neha will follow. So over here, I'll just hand it over to Arun. Arun, over to you.
Thanks, Gaurav. Hi, everyone. I'm Arun Chauhan. I've been with LinkedIn for more than 5 years now, and last few quarters I've been focusing on preventing phishing and malware on our site, specifically the public content space. Next slide, please. So yeah, I'll be talking about detecting and preventing malicious links. So the first question is, what are malicious links? So mainly there are two kinds, malware and phishing. So malware is defined as an intrusive software that is designed to harm or exploit computer systems or networks. So on the right, you can see an example of a malicious site. So a malicious site could be attempting to download dangerous programs on a computer, or it could be trying to steal your photos or deleting your passwords and so on. So for example, on LinkedIn, you might get a message saying, hey, we are interested in your profile. Could you please click this link to see if everything is in order? And when you click on that link, it might take you to a malicious site. Now, phishing, it's a type of social engineering where an attacker attempts to trick a person into revealing sensitive information. So on the right, you can see a screenshot. It appears to be a LinkedIn login page, but if you look at the URL, it's some Jantos recruitment.bond. So it's the fake site pretending to be LinkedIn. And it'll ask you to enter your mobile number, your login password, and it'll steal those credentials. So example could be somebody ask you to click on a link and it'll start playing a video. For example, if it's a live conference, it'll play a video. And after some time, it'll ask you to enter your credit card details if you wish to continue. So there also they can steal your credentials. Now I'll talk about why detecting malicious intent is hard. So first could be the type of links that you're seeing. They could be shortened. So for example, the first line you see, lnkd.in/something. Just by looking at it, you can't know whether it's good or bad. Where does it take you? So even if you unwind the link, for example, bit.ly/abcd, it might take you to a site one that can again take you to another site and so on. So we have to first unwind and see what is the final URL. And even the URLs all along the trail, we'll have to check all of those if we wish to see whether it's malicious or not. Second trick attackers could use is they could use JavaScript-based redirection. So for example, if there's a link, maybe the first 10 times you visit it, it will take you to a safe site. But after that, it starts taking you to a malicious site. Or maybe it could be based on percentages. So maybe 10% of the time it's taking you to a malicious site. Third one could be IP or geo-based evasion techniques. So for example, if there's a link and LinkedIn IP are available publicly, so attackers can set up their sites so that if we are accessing it with LinkedIn, so for example, if you want to check within LinkedIn whether it's a malicious site or not, they can ensure that if the access is coming from LinkedIn, they will take you to a safe site. Other option is they can do geo-based evasion. So if they know that let's say they are targeting people in Brazil. So if they figure out that the IP of the viewer is not in Brazil, they might take you to a safe site. Otherwise, they will take you to a bad site. Next slide, please. So this was about why it's hard to detect the intent. Now, this slide will talk about the challenges of doing it at LinkedIn scale. So first is like we have to check around more than 30 billion URLs per day. So these are not just the URLs getting created. This is also the URLs that are being viewed. So you might ask, why do we want to check a URL at viewing time if we've already checked at creation time? So the reason is we might not always know at creation time whether a URL is good or bad. So our data could be, it keeps on being updated. So URL which we didn't know was bad and we allowed it to be created, later we might know that it's bad. So we need to check it at render time as well. Second is more than 99.9% of our content is clean and a very small fraction of it is actually bad. So whatever solution we employ for detecting bad URL, it should not affect the flow for the overwhelming majority of the clean URLs. So that's another challenge. Third is we have to keep the latency low. So P95 latency requirement is less than 10 milliseconds. So imagine you're scrolling through your feed. Every post or comment you come across which has a URL, it needs to be checked before it's being displayed to you. So this check has to be very low latency, otherwise it might not result in a good experience. So now I'll talk about some different aspects of checking a URL. So first is where do we perform the check? So one could be we call third-party APIs. We tell them, hey, this is the URL, or maybe we send them a hash of the URL, and they'll be able to tell us whether it's malicious or not. Other option is we can do some in-house checks. So here we can have an internal list of malicious URL that we've come across. So it could be compiled by analysts and security researchers, or we could integrate with third parties and they will provide us feeds of bad URLs that they've seen. So for example, they could tell us, hey, these are the phishing sites we've seen. These are the malicious sites or malware sites they've seen. So these could be in millions, the amount of such URLs. The other type is the types of checks we do. It could be a real-time assessment where we take a URL and we try to open it in a sandbox environment and see what it's doing. So we could monitor the CPU usage, the network usage, and disk usage to see if it's trying to download anything on your computer or it's trying to run something on your computer. So that way we'll know whether it's doing something malicious or not. Other is we need to check for shortened URLs. So any URL that we come across, we first need to know whether it's shortened or not. If it is, then we need to first unwind and then check. So we need to be aware of all the shortener sites like Bitly, TinyURL, and so on. Third is checking against known bad sites. So like I mentioned, we might have internal list or third-party feeds, and we have a huge data set of millions of URLs that we know are bad. And any incoming URL that we need to check, it has to be checked against this data set. So since this is a very broad topic, all of this, I'll only be focusing on checking against the known bad sites in this talk. Next, please. So the first step of checking is first we need to detect what are the URLs in a content. For this, we use LinkedIn's own open source library called URL Detector. You can go to this GitHub link and try and play around with this library. So what it does is it will take an input of string and output it will produce is the list of detected URLs in that string. So here you can see a sample. So it will try to see hair.com whether it's a site or not. So the thing about this library is we err on the side of caution. And even though hair.com might not be an actual site, but since it looks like a site, we'll still treat it as a valid site. So we'll try to parse it. If there's no scheme specified, it will default to HTTP. If there's no port, it will take default as AT. If there's no path, it will take a default as / and so on. Second link, it's a FTP link. So we know the scheme is FTP and so on. Like it will also pass this URL into all these fields. Third one is an IP link, and it also has a port. So again, it'll parse and get all these fields for these URLs. Second step is normalization. So in example 1, you can see we have a hexadecimal IP. It will convert it into decimal. Second example, it has www, which is optional in most sites. It has a port, 80 is the default port, and it has a fragment. So all these optional features could be removed, and we normalize it to just http abc.in and a.b. Third is username password at example.com. So here the case might change, and there's a username password. So we strip that. And since there's no path, we'll add a trailing slash to it. So this is the normalization step. This will facilitate in matching any incoming URLs. Now, the third step is canonicalization. So here you can see the input URL is login.mysite.com, then 2 paths, and then a parameter. So here we will generate all the variations of this URL. So we'll take the original URL and first line, we'll chop off the parameter, and we'll start chopping off the paths. So we'll produce a set of URLs. Now it might happen that maybe the whole site isn't bad, or maybe just the login page of the site is bad. So we need to generate all these variations. So we'll also chop off the subdomain, which is login, and again, generate all these variations. So you can see for each URL, we'll generate many such variations and check each one of them. Step 4 is validating the URL. So I talked about how we have a data set of known bad URLs beforehand. So we use them to pre-compute a trie data structure. So for example, we have a known bad site.com. We hash it. We'll take the first few bytes of that hash and insert into a trie. So for example, the first few bytes are ABC. We will insert into this trie. So this will be done for all the tens of millions of known bad URLs we have, and we'll insert it into the trie. Why we are taking the prefix is to conserve the space. So you can imagine that if there are millions or tens of millions of URL and we hash it, it's producing a 32-byte hash. Not everything could fit into a memory. And we want to check incoming URLs with a very low latency, so it has to be in-memory check. So that's why every box that is handling these requests will maintain this trie structure in memory. So coming to the diagram on the right, we've seen how given a text containing URLs, we'll first detect it, normalize and canonicalize it. And then for the incoming URL also, we'll do the same thing. We'll take a hash, take the prefix and check whether it's part of that pre-computed trie or not. So if there's a mismatch, we can straight away say the URL is safe. If there's a match, it could be a false positive match due to like prefix hash collisions. So we'll go and check the source of truth. Here, the source of truth could be like we could maintain it in a cache in a database, or it could make a call to a third party. And there, if we know that if it was not found, we'll return safe. Otherwise, if it's found, we'll say it's bad. Next, please. So now we have found malicious links. What are the next steps? So we could take down the content. This is usually done during creation time. So for example, somebody is making a post and they're putting malicious links in it. During saving of the content, we can make a call and see whether it has malicious links or not, and we can just prevent creation of that content. Other option is we can replace the links with a warning page. So this is usually done during viewing time or render time. So if somebody has already created a content with a malicious link, but we didn't know at the time of creation that it was malicious, we will just replace it with a warning page. So if somebody clicks on it, they will be taken to a warning page saying, hey, this is a malicious site. Do you want to go ahead or go back? And so on. Third could be on top of all these, we could take action based on automated rules. So for example, if we see a member is posting a lot of content with malicious link, we could restrict the author, or we could send the author or the content to human moderators. Now, each of these topics, like getting into them, will require their own separate tech talks. But luckily, we have Neha next to specifically talk about the last line item, which is content moderation. So thank you, everyone. Over to you, Neha.
Thank you. Hi everyone, I'm Neha. Today I'll be talking about content moderation and I'll be unrevealing few mysteries why it is so difficult to moderate content at such a huge scale. So earlier Gaurav talked about the trust mission, which is to create a safe, authentic and transparent experience for the members and the organizations. In order to maintain the experience, we have to ensure that the content that is moderated, it has to be done in a fair manner without any personal biases. LinkedIn has invested heavily in creating a strong ecosystem consisting of legal, policy, moderators, and engineering team. Content moderation tools lies at the heart of this ecosystem. Let's first talk about the life cycle of a content via content moderation tool. Any content that is reported on the feed, it is ingested into the content moderation tool available as a moderation request. The moderators, as per their skill and expertise, they pre-scan the content to verify if it violates any LinkedIn's terms and service policy. In case it does, they annotate the policy that it violates. The author and the reporter, they receive a notification about the moderation decision. In case the member is not happy with the decision, they are free to appeal the decision, but within a defined time frame. Although the life cycle might look simple to you, but things might get challenging at times when talking in terms of LinkedIn's vision and scale. To start with, LinkedIn operates at a scale of 800 and plus million members. One can imagine equally proportionate content getting ingested into the content moderation tool. How can we create a stable, optimized, and intelligent system that is able to handle the load? We have members coming in from diverse backgrounds, talking in assorted languages, each having their unique perspective. The severity of a content depends on the damaging impact it can have once live on the feed. Of course, a content related to hate speech or terrorism, it is high on severity and should be prioritized over a mere, say, double tap meme. How can we create an intelligent ecosystem where the moderators, they understand the individual nuances while moderating the content? The members of LinkedIn, they have a plethora of options to select from when it comes to content format. They can post content in a simple text format, multilingual text, image, poll, video, live video, audio, and numerous hybrid options are available. Every now and then, we keep on introducing new content format. How can we create an agile system to keep up with the fast-paced tech world? The users of the content moderation tools varies throughout the company, each bringing in their own expertise and skill set. Information required by multiple personas might vary based on the context and the use case they are trying to solve. How can we create an intelligent system here where the system first understands the context of the user and then based on the context renders relevant information on the UI? So all the challenges that I talked about earlier, it boils down to the single problem statement here, which is how to ensure right moderators are moderating the right content at the right time in an efficient manner. Don't get intimidated by this complex problem statement. Let me try to break it down for you. Focus on the first problem statement. What are the inputs you can notice here? I can see moderators, content with an adjective right here. That's true. On decoding a content moderation tool, the input that is available with us are moderators having their own expertise available in the form of skill set, the content that needs to be moderated having their own individual nuances in the form of context, and the adjective right, it can be represented as business constraints here. To give you one example here, say Neha has been trained to work on live videos. So the system should ensure whenever live video enters the system, it should be routed to Neha if she is available. Now, all these three input can be fed into a rule engine, which as per the business constraints can provide us a mapping between the moderator and the content. Let's take language as the use case here to understand the problem statement further. On the left hand side, I have content that needs to be moderated, having their own individual context here, which is language here. On the right hand side, I have moderators who need to moderate the content, having their own expertise in which is language proficiency here. Now, every mapping from left hand side to right hand side can be considered as the exhaustive solution set. But then again, not every mapping is same. To give you one example here, Alex, in the diagram, Alex, who is proficient in English and French, it might be easy for Alex to work on a French content, but the same can't be said for a Spanish content. Similarly, for Amanda, it might be easy for her to work on Spanish content, but not so on Portuguese content. So if the system is considerate of these constraints, it would be able to reduce the problem set to a single best possible solution. Let's talk about another example so that you understand this clearly. Taking example of severity as the use case here. Say we have two content that needs to be moderated. One content is around hate speech, which is of course high on severity. And then we have a double tap meme here, which is low on priority based on the damaging impact it can have. And then imagine like there's only one moderator available. At a time, one moderator can concentrate on a single content. Although both the content are inappropriate and they should be moderated, but when in a contest like situation, we should be moderating the high priority content over the low priority one. As you can see on the right hand side, the content which is more critical, which is content 1, content 3, that should be routed first, then medium content, which is content 5 here, and then the low content, which is content 2 and content 4. Okay, so yeah, coming to the second sub problem, how can we ensure that the content that is getting moderated is done in a timely manner? Just revising how the system looked like from the earlier slide, let's extend this system and introduce artificial intelligence here. Okay, don't get intimidated again. Let me try to decode it for you. On the left hand side, we have content. As soon as it enters the system, it is then fed to the AI models where they pre-scan the content to verify if they can automatically take the decision here. Only if the confidence level is extremely high, the system automatically takes the decision. It can be directly clearing the content or it can be taking down the content as well. In case the confidence level is not so high, it is then passed on to the second hurdle, which is prioritization based on the dynamic context. Now, what do we mean by dynamic context here? Every content has dynamic attributes attached to it. To give you one example here, it can be virality of the content, which is like number of the members who are looking at the post. It can be reputation of the author if the author has been known to be posting offensive content in the history. It can be the reputation of the reporter if the reporter has been known to unnecessarily reporting content on the feed. So all these are the examples of dynamic attributes. And then based on these dynamic attributes, the AI models, they try to prioritize which type of content has a high probability of being spam and should be prioritized over other content. The output is in the form of a prioritization score, which is then fed to the assignment system, which helps with the timing aspect. Now, if you look at the diagram closely, we have AI signals here. The scope of the AI models, they need not be just limited to pre-moderation. Even during live moderation, when the moderators are looking at the content, even that time also, AI signals can play a huge role in optimizing the reviewer's bandwidth. To give you guys one example here, AI signals can provide a hint to the moderators that probably these are the policies the content might be violating, or grouping together of similar kind of content, and so on. The opportunities are vast here. Okay, coming back to the problem statement, we are already done with two sub-problems. Coming to the third sub-problem, which is how can we ensure that the content that is moderated is done in an efficient manner. Okay, in the vast sea of data, we should ensure that the content that is available on the tool that is provided in a structured and well form. One should be optimizing the average time spent per moderation. There should be a balance between information overloading and time number of clicks required to gather the relevant information. Let's take example of profile moderation. Say somebody has to moderate a profile for left hand side use case, which is account takeover use case, and then some moderator too, they need to moderate the profile for suicidal use case. If this is the UI provided to the moderator, they will be lost here. A profile can have numerous data points. It can have email, contact information, payment history, connections, derived attributes, and so on. Of course, one can't imagine finding the relevant information here in one go. However, if the system can be a bit intelligent here and first try to understand the context of the end user, why the person is visiting the moderation tool, and then after it has understood the context, it can maintain a mapping of for which context, what are the data points that are relevant and should be focused on. And voila, here as you can see, if the system can focus on the relevant information, as you can see on the left hand side, we have focused more on recent activities, and on the right hand side for suicidal use case, the system has focused more on the recently authored content. The average time taken per use case would be reduced, and hence improving the efficiency part. Yeah, that's it from my side. Over to you, Gaurav.
Thank you, Neha. Thanks, Arun, for the insightful deep dives. So yeah, it's pretty exciting. Like that's we just spent the last 30 minutes discussing two deep dives, and it was just pillar number one. Imagine what all we have in store when we go into authentic and transparent as well. So over here, we'll dive into our Q&A section. So we have Saloni with us, who is I would say, a relatively new hire with us, and she has already solved some incredibly challenging problems with our trust engineering team. So she'll help us do the moderation for the questions that we have. If you have added, that's awesome. If you haven't, yeah, like now you have heard both the deep dives and the overview. Please add them there. Saloni, over to you.
Thank you, Gaurav. So while we wait for questions from our attendees, to kick off, we have a few questions for our speakers. So Neha, can you answer this one? So how does the assignment work if there is a lot of content, say in one language, say French, and there aren't many moderators proficient in French?
Yeah. Thank you, Saloni, for the question. Diving deep into the question and into the assignment logic here. So the examples that I mentioned here, language was just one use case. Again, in reality, when we are doing the matching between the content and the moderators, there are multiple factors influencing the decision here. We have severity of the content, then geolocation, wellness, and AI signals. These are the multiple factors that play the role in influencing the decision. So in case we don't have enough number of reviewers available who are proficient in the language, we have other business constraints in place like severity. If a content is high on severity, say it is about terrorism, so at that time we give more preference to severity. So the assignment is happening on a best effort basis. If the reviewers, if the expert is available, it's okay. If no, then wait for X minutes. Otherwise, assign it to whoever best person is available here.
Thank you, Neha. So we have one question from Anjali. So does LinkedIn apply its fraud detection algorithm on profile photos as well? Arun, would you like to take this up?
So yes, we do. We have machine learning classifiers, which will also run on profile photos. So yeah, that's being done.
Thank you.
Just to add to, Sarun, just to add to that, like, yeah, we do that on the profile photos, and we also do, like, we check it against a set of celebrities that you are not using. Maybe, I don't know, Sachin Tendulkar's photo or Narendra Modi's photo or Elon Musk's photo. So if you do that, that's also being checked in an offline way if you're misusing some celebrity's photo.
Thank you, Gaurav. Following up on this question, so how does LinkedIn deal with new threats? That is, some previously unseen threats. Arun, would you like to answer this?
Sure. So there are a few ways to do that. So one is, I talked about real time assessments. So where we could just monitor the new link in a sandbox environment. That is one way. We could send it to third parties. So if they have intelligence to figure out whether this is malicious or not, that could work. Other is, like, if we've already allowed it and maybe members are reporting it, our reviewers can take a look and then classify it as bad, and then it will automatically feed into our system so that next time we encounter that same URL, it could be marked as malicious. So yeah, these are some of the ways. And then few more things we're working on is we are also looking into getting data around whenever a new domain is registered. So based on those attributes, we could compare it to the registration details of known bad links. So for example, they're using the same registrar, same email ID and so on. So because of this, we can work with the proximity score, how close it is to an existing malicious site. And based on that, we can assign it a score, the riskiness score. So it might not be a black and white decision that, hey, this is clean or bad, but it might be a suspicious URL. So we can treat it accordingly. Like maybe we can display a warning when it's being rendered. So yeah, there are a few ways of doing that.
Okay. Thank you. So the next question is for Gaurav. So what happens if human moderators make a mistake in reviewing a content or taking a decision on a content?
Yeah, I think, yeah, like that's a very good question, because we treat like the human decisions as the holy grail of the decision. That's that's the purest form of decision. So but yeah, there are times when people get that wrong as well. So we have multiple layers. So whenever such a thing happens, like there will be an audit team which will be like, if I am a reviewer, they'll be auditing what have I done, how is my performance. We have training for people. Like if they're not doing well, we'll train them. Oh, like this is what you got wrong in this post. At times there might be ambiguous policies as well. So one of the reviewers is getting it right, but the other is not. So can we make that more understandable? So there are ways to tweak QA misses or like reviewer misses as well. But yeah, definitely we do it, but we have enough checks and balances in place so that eventually it is fixed.
Okay, thank you, Gaurav. So we have one last question for Neha. What is one of the project that you have worked as part of trust engineering that you're most proud about?
Okay. One project that I'm most proud of, it has to be my recent project about this assignment logic. Earlier, the things were quite manual, and then we did proper R&D. We tried to understand the pain point of the moderators, because ultimately whatever we are doing here, we are doing for the moderators, we are doing for the end users of the tool, right? We have to make sure that their life is easy. So we tried to understand their pain points. It was more manual, and when we were at it, when we were trying to automate this entire moderation process, routing logic, that time we saw opportunities on how we can make it more intelligent. When I say intelligent, how can we um, involve multiple factors, where how can we take multiple factors in, and then based on those multiple factors we determine the assignment logic. As I discussed earlier, it's not a simple problem statement of matching. It's a more evolved complex problem statement where we have multiple constraints affecting the mapping, right? It can be language, severity, wellness, AI signal, and there are numerous more opportunities. And today it has become the backbone of the content moderation tool. So that's one project that I'm really proud of.
Thank you, Neha. So the same question for Arun. What is one project that you're most proud about that you've worked here at LinkedIn?
So yeah, hard to pick a single one, but I can talk about the one I completed a few quarters ago. So this was to protect against payments fraud. So that was a big issue for LinkedIn. Like we were losing millions of dollars to fraudulent transactions. So we integrated with a third party. So they had a machine learning system to identify fraudulent transaction. So we had to send over 50 to 70 fields related to transaction. For example, member, the number of connections they have, how long the profile has been active. So we had to gather this from multiple different upstream sources and then send it to them. And it had to be returned within a short window, because somebody is making a payment on site. They need to, we need to verify that's the authentic transaction before we move ahead. And there were other aspects of it. So there's a browser code which will also send some fingerprinting data about the user. So for example, what kind of browser you're using, what kind of credit card you're using and all that. So using all this logic, we were able to figure out whether the transaction is fraudulent or not. And on top of that, we had to work with multiple stakeholders like payments team, payment review team, and so on, so that they could create rules on top of that. So we'll get a score back from the vendor, and we might say if the transaction score is above a threshold, and maybe it's type of a recurring transaction, or it's a one-time transaction, or if it's for a particular product with this threshold, if it's falling below that or above that, we need to reject. So it was a huge complex project. So yeah, my answer would be that one.
Thank you, Arun.
Any more questions?
No. So thanks a lot, everyone. Handing over to Gaurav.
All right. Thanks, Saloni, for moderating the Q&A session. Thanks, Neha. Thanks, Arun. And thanks everyone who's on the call for taking out time on your Saturday afternoon. Just before you leave, we have a QR code for you, so that deck up. Can we share the deck? Segments which we could have done better. Let us know. If you liked something, let us know. That'll make us feel good. But yeah, please do that before you leave. Thanks for joining this Tech Talk. Bye-bye.